So we've played with base 5 numerals a couple times now, last week and this week. Hopefully we're getting better at those. The base can be pretty much anything we want it to be. We happen to use base 10 because maybe we have 10 fingers on our 2 hands combined. So it's this kind of weird circumstance of history that we ended up using base 10. Could use base 2. And actually we do. Computers do calculations in base 2 and then present things however humans want to see them, right? So they have their secret language in base 2, and then we do other stuff with them. So what does base 2 mean for a numeral system? So first thing to think about is the digits we have to work with. In base 2, you can have no more than 2 digits. And so the common choices are 0 and 1. So those are my digits. Everything is based on groups of 2. And so if we consider the place values, every number system is always going to have a ones place. And then the next place is going to be the twos place, because we're grouping by 2. And then groups of 2 twos would be groups of 4s. If I group 4s by 2, I get 8. If I group 8 by 2, I get 16. If I group 16s by 2, I get 30 seconds. And these are all powers of 2. So 2 is 2 to the power 1, 1 is 2 to the power 0, 4 is 2 to the power 2, and we have 2 to the power 3 for 8, 2 to the power 4 for 16, 2 to the power 5 is the 30 seconds, and they just keep going however far you need to go. So I'm going to start with a numeral in base 2. We're going to convert it to base 10, then we'll try going the other way. So when I write a numeral in base 2, I can only use zeros and ones. So an example would be something like 1, 1, 0, 1, 0, 1. Okay, so this is a possible base 2 numeral. I can only use zeros and ones. And then it's a matter of identifying each place. Okay, well this place right here is my 1, so maybe above each place I'll identify its value. Place versus place value. So this 1 is 1, 1. And this 0 means I have 0 2s. This 1 means I have 1 4. This 0 means I have no 8s. This next one means I have 1 16. And then if I double 16, I get 30 seconds, so I have 1 32. So to translate this number into base 10, I would say, okay, I have 1 32, and I have 1 16. I don't have any 8s, so who cares about them? I have 1 4. I have no 2s, so who cares? And then I have 1 1. So basically, the cool thing about base 2 is either the place is there once or it's not there at all. Those are the only options. It's there or it's not, on or off. So 32 plus 16 plus 4 plus 1 would be my answer. So let's see, 32 and 16 is what, 48. If we add that to 4, then we get 52 plus 1 is 53. So it looks like this 1 1 0 1 0 1 in base 2 is 53 in base 10. So we'll try to convert it back to base 2 to make sure we did it right and we can go the other direction. So to take a number in any other base and convert it to base 10, all I have to do is identify what each place value stands for and then expand it out. And then I just clean up the multiplication, add stuff together, and boom, I'm done. Right? So we expand to convert from one base to base 10. Let's convert back. So we're going to take 53, which is a base 10 numeral, and double check what numeral it is in base 2. And so I'll do the same process I did before. First, I'll use the counting back change method, which means I need to list a whole bunch of places till I'm done listing them. So I have a list of places right here in front of me. I'm just going to make a note. If I kept going, the next place after 32 would be what? Anybody? 64, yeah. double 32 and we get 64. And 64 is too big, right? So I always want to double check. Did I go far enough? All right. So then I just ask myself, okay, how many times does 32 go into 53? And in this number system, it's either oops, 53. It's either one or none, which is kind of nice. It's a little simpler. So 32 goes into 53 one time. 1 times 32 is 32. And then we subtract and we get a 1 there and a 2 there. So then I just move over to the next place. The next place is my 16s. So I say, all right, 16 goes into 21 how many times? And it's always either 1 or none. So it looks like 1 to me. 1 times 16 is 16. Subtract, and that looks like a 5. So then I move on to my next place, which is the 8s. 8 goes into 5 how many times? 8 goes into 5 0 times. 0 times 8 is 0. Remainder is 5. Moving along. 4 goes into 5 how many times? 4 goes into 5 one time. 1 times 4 is 4. Subtract and get a 1. And then I move on to my 2s. 2 goes into that remainder how many times? 0 times. Remainder 1. Oops, there's supposed to be a subtract there. And then finally I'm done. 32, 16, 8, 4, 2, 1, done. And just a reminder, it's the remainder that leads us to the next place value to check. And so this is my answer down to that last one. So the answer is 1, 1, 0, 1, 0, and then don't forget the final ones there. That needs to get put in there, which matches what we started with. So base 2 is kind of deceptively easy, but it still takes a little getting used to. Let's try another. We'll go the other direction. We'll take a number in base 10, change it to base 2, and then we'll expand it to see if it worked. Oh, we could do the repeated division. I guess we should check that while we're here before I move on to a new number. If I wanted to use the repeated division method here, then I just take 2 into 53 and see what happens. So I'm going to use the short method. 2 goes into 5 twice, 1 left over. 2 goes into 13 6 times with 1 left over. And then I just keep dividing by 2. So 2 goes into 26. I think that's 13 times, remainder 1. No, I lied. Remainder 0. It's an even number. Yep. And then keep going. 2 goes into 13. 6 times, that's 12, remainder 1. Just keep dividing by 2 till we get a 0 on top of the division box. 2 goes into 6 3 times, remainder 0. 2 goes into 3 once, remainder 1. Keep going. 2 goes into 1 0 times, aha, but I need the remainder, 1. And here's the answer, 1, 1, 0, 1, 0, 1. We always read it from the top down, and the flag that we're done is that 0. Let me read the number downward. Okay, so let's practice. So the next try, you can either pick the making change method here or the repeated division method, or both if you want. And we'll just get a new number. How about 101 base 10? Let's see if we can rewrite that in base 2. So either use the counting change method, which is a bunch of separate divisions, or the repeated division where we stack them. Calculator is not a bad thing. Give it a shot. Cool thing about remainders in base 2, they're zeros or ones. Okay, I think I got an answer. I think if I did this right, it is from the top, my remainders 1, 1, 0, 0, 1, 0, 1. And I thought to do that, I listed out the places. I didn't need 128, so I need 1, 2, 3, 4, 5, 6, 7 places. So this would be 7 digits. 1, 2, 3, 4, 5, 6, 7. Yep. Could be right. It has a chance. If I went too fast, you're still working on it, I will shut up for a minute. If you have a question, please jump in and ask. All right, are we ready to check it, or does anybody have a question about getting that crazy numeral? All right, so let's check it out. So to check it out, I need to identify every single place, and often I like to write them right above them. So I'm going to start over here. Those are my 1s, my 2s, my 4s, my 8s, my 16s, 32s, and 64s. And then it's either there or it's not, so I could just stack it to check. So I have 164 and a 32. I don't have a 16 or an 8, but I have a 4 and a 1. So 4, 5, 6, 7, 8, 9, 10, 11, carry the 1, 6, 7, 8, 9, 10. Hey, it's 101, 101, base 10. It worked. So there's a couple problems where you get to practice taking a base 2 numeral and converting it to a base 10 numeral, or taking a base 10 numeral and making it into a base 2 numeral. And the 10 to 2 is the harder part. All right, next, new page. We're going to take a look at actually 2 different number systems kind of at the same time. What if we tried base 12 or base 16? So there is a weird base 12 problem in your homework where they give you these bizarre digits. So like Mayans use the dot and the bar or the stick and the shell. There's another base 12 system that's based on astrological signs. I don't know if anybody noticed that. If you check it out, take a close look at the base 12 problem. They use astrological sign symbols for the digits. Now I'm going to do a more traditional base 12 using digits that we're more familiar with. Now remember, a digit has to be a single symbol. Now my favorite single symbols are symbols like 0 and 1 and 2 because I'm used to them. 3, 4, 5. What's the most number of digits I can have for base 12? Anybody? $12 digits, yeah. So I'm gonna use all of them if I can. I like that because I'm used to using all the digits in my base. So 0, 1, 2, 3, 4, 5. I can have a 6, and I can have a 7. I can have an 8. I can have a 9. Ooh, I need a 10, but I can't write that because that's 2 symbols. It's got to be a single symbol. Darn. Turns out what's traditional here is to call that A, and the next one B. Sometimes people do a T and an E for 10 and 11. So in base 12, if I were to count, remember we counted in base 5 the other day using the numerals. Counting starts off pretty normal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the symbol for 10 right now. There's the symbol for 11, and there's the symbol for 12. Because that's one group of 12 and no ones. So I'm just going to write that down here. I'm going to continue counting. 1, 0 in base 12 translates as one group of 12 and 0 ones, which is this 12 in base 10. So 1, 0 in base 12 is 12 in base 10. Whoa, that's trippy. All right, so then we keep counting. 1, 1 in base 12 would be what number in base 10? Anyone? One, 1 in base 12 is what in base 10? How far have I counted up to here? 13, yeah, nice job, Emma. Yeah, it's a group of 12 plus one more. So that's 13. This would be 14 in base 12, 15 in base 12, 16 in base 12, 17. It's hard to say and write at the same time. Let's double check. What is that in base 12? Let's come down here. 1, 5, base 12 means in base 10, when I expand it, I have one group of 12 and 5 ones. 12 plus 5 is 17. Yep, so that's the 17th counting digit. So here's the 18th, 19th, 20th, 21st, 24th. What? Is that right? Did I do that right? Or did I miscount? Let's see. I think I might have screwed something up here. That would be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, I miscounted somehow. Okay, 1A should be 22. 1B should be 23. Oh my. What's next? Let's double check that. 1B in base 12. That would be one group of 12 plus B is 11 ones, which would be 12 and 11 or 23. How do I write 24? Anybody? 24 in base 12 is, in base 10, sorry, is what in base 12? This is a hard one. Two zeros, says Monse, sorry. Let's double check that. 20. Let's see, that would be two groups of 12 and no ones. You nailed it, yeah. So the B is like a 9 in our number system. It's the last digit. It says, hey, time to jump places. And so we have to jump that 1 up to a 2. Yeah. Okay, that, I remember when I first saw base 12, it kind of blew my mind. We're going to pause there on base 12 for a minute. I'm going to jump to base 16. Just because base 16 is a little bit more meaningful, and I'll show you why in a sec. So base 16 means I have to group by 16, and I need 16 digits. So the digits, kind of like base 12, zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 15 plus the 0 gives me 16 digits total. Those are my digits. Okay. So I had 10 common digits. I needed 6 more that were a single digit. The common choices are A, B, C, D, E, and F. Normally they're capitalized, but it really doesn't matter. Okay. All right, so base 16, grouping by 16. Okay, so we have to group by 16. So the places, if we listed out like the first 3 places in base 16, the first group's always the 1s, and then the 16s. And when you do your grouping, each place is 16 times more than the previous one. So right, 16 ones is 16. The next place would have to be 16 16s, which is how many? Two 56s, yeah. So the next place in base 16 is the 2 56s. And I probably should have wrote that in blue to be consistent. So that's the next place. So in base 16, if I wrote a number like, let's do a relatively simple one, like 1, 2, C. So suppose we saw that numeral, 1, 2, C, base 16. Now I tend to write the word out. Some people might write that in some books or some online sites like that, okay? I don't know. Which is better. I like the word. If I expand that, that says I have one group of 256, I have 2 groups of 16, and I have C, so that would be 9, 10, 11, 12. C is a 12 groups of 1. So then that would be, what is 256, 2 16s is 32, and 12, 6, 7, 8, 9, 10, carry the 1, 5, 6, 7, 8, 9, 10, carry the 1. It looks like that's 300 in base 10. So if I can identify what the digits mean, and I can identify what their places mean, I can always take that numeral and convert it to base 10. That's not too bad. I just need kind of a lookup table. Okay, so here's kind of my lookup table in two parts, here and here. The reason I'm jumping to base 16 and kind of away from base 12, a lot of books on math for elementary school teachers do base 12. And it's all right because you have to add two symbols here, but it's not really used too much in our reality. Turns out base 16 is. Base 16 is often called a hexadecimal system. Hexa meaning 6, and decimal meaning 10. 6 and 10 is 16. And hexadecimal numbers are often used to encode colors on a computer. So computer colors. And I'll just show you an example of this, and then we need to move on to rounding. If I pick, I don't know, let's look at the Canvas website here. So somebody designed this website and they thought this color blue over here was pretty and that color blue up there was pretty. Anytime you have a color on a computer, it's referenced somehow, often in a hexadecimal manner. So if I sneak into the code that makes this page, I should be able to find what version of blue that is there. And that is probably it right there. So 369. I think is that blue. All right, we'll double check that. Oops, and that back. All right, so computer colors, quick tutorial on it. Often with computer colors, there's a system called RGB, which stands for red, green, and blue. And the way it works is red gets 2 hexadecimal digits, and then green gets 2 hexadecimal digits, and then blue gets 2 hexadecimal digits. And on that web page, I saw a shorthand for the following hexadecimal numbers. Hexadecimal usually starts off with a hashtag, and their shorthand meant 33 for red, 66 for green, and 99 for blue. Each color gets a 0 up to 255 for its intensity. So 255 is as much blue as you can possibly have. 0 is no blue at all. Same with green and red. And 255 is one less than 256, which is this third place. I only have 2 places to work with at a time with hexadecimal numbers. So the way that works is they're not often separated by a comma, but I'm just going to throw a comma in between them. The red channel is 33, which these are all base 16 numbers. So the decimal version of these, this would mean 3 16s and 3 1s. 3 16s is 48, 49, 50, 51. So that would be an intensity of 51 out of 255. This one here is 6 16s and 6 1s. 6 16s, oh gosh, can't do that one in my head, can I today? Maybe that would be 60 plus 36, which is 96, I think, plus 6, which should be what, 102. We'll have to double check that on the calculator. And then this would be 9 groups of 16 plus 9 1s. And so that one would be what, 9 16s is like 151-ish. Better double check that, plus 9, which should be 160. Let's double check on the calculator some of these. Calculator. Calculator. So 6 times base 16 plus 6, 102, and that's what I thought it was. And the other one was 9 times 16 plus 9. And that's 153, which is, ooh, I was way off on that one. I messed that up, I don't know. Did I type it right? 9 times 16 plus 9. Yep, okay, 153. So I did it in my head and I made a mistake. And that's all right. Now I'm not going to add these up or anything. This is just the decimal version of the numbers down here. So let me rewrite all those in red. So the 51 and the 102, these are decimal versions of the hexadecimal values above. And it just tells the computer of how much red to use, how much green to use, how much blue to use. So let's check out a hexadecimal color editor. Confirm I got the right color from the web page. Hexadecimal color. And math is fun. Hexadecimal color codes. This one probably will work. Yeah, so I think I can just go here and type in a color, right? Like 33. No, this one won't let me type. This isn't the one I want. Let's go back. Grab this site ahead of time. Color codes, color hex. I think that's the one I want. Yeah, so up here I can type the hex color, so I could type, I could do the hashtag first, 336699, and it will show me that shade of color, and if I hit enter, it'll tell me more about it. It'll tell me its decimal version, which is kind of cool. It just did a conversion from hexadecimal pairs to decimal triplet. So there's that 51, 102, 53 that I tried to calculate for each of those pairs. So when in hexadecimal on a computer, when I see on an graphics program or a web program that someone used the color 336699, the hashtag in front tells me, oh, this is a hexadecimal reference. That means the first two digits are how much red, the second two are how much green, the second two are how much blue, but that's not 99, it's 916 and 9 ones. So I have a couple of homework problems related to hexadecimal colors that you get to play with. Okay, fun with crazy